Hi students, today we have to discuss the chapter Magnetic Effects of Electric Current. The chapter heading Magnetic Effects of Electric Current. It indicates that electric current can produce a magnetic field. Okay, electric current can produce magnetic effect. We want to check that effect. I take a battery and connect this battery into a wire. Then the current is passed from the positive terminal to the negative terminal in this direction. Okay. Then this electric current can produce a magnetic effect. Place a compass needle here. Place a compass needle behind the or near the wire. You can see a deflection in this compass needle when the current is passed through it. When we turn on the switch, at that time the compass needle will deflect. What it indicates? This compass needle indication is due to the effect of magnetic field around this wire. So when an electric current passes through a wire, it produces a magnetic field around it. Okay. This experiment was conducted by Christian Oyster accidentally. He was the first scientist who created a branch magnetic effect of electric current. And it leads to several applications in our daily life. Electric fan, motors, microphone, speakers, and a lot of machinery parts are working based on this principle. In this chapter, we have to study about the basic property of a magnet and the magnetic effect of electric current. Then we want to study about the instruments, that means microphone, electric motor, and the principle behind it. Okay, a current carrying conductor can produce magnetic effect. Magnetic effects of electric current can be analyzed by a current carrying wire. A current carrying wire behaves like a magnet. Take a wire and connect this with a battery, then it can produce a magnetic effect around it. Okay, current carrying wire behaves like a magnet. That is why that compass needle got deflected. Okay. When electric current passes through the current carrying conductor, it produces a magnetic field around it. The unit of magnetic field strength is named as Oyster in the honor of the scientist Christian Oyster, who was first explained the phenomena of magnetic effect of electric current. The SI unit of magnetic field strength is Tesla. Okay, just note it. Then another question is, what is a compass needle? It is a compass needle. Just listen. I take a compass needle and a wire, a current carrying wire. Then this compass needle produces a deflection due to the flow of current. Why it is? Just listen. A compass needle is a small bar magnet. Inside this, at the center portion, there is a small magnet, and the north and south poles are connected at that magnet. So, a compass needle is a small bar magnet. The ends of this compass needle point approximately towards north and south pole. This magnet always stay in north-south direction. The end pointing towards north is called the north pole, and the end towards the south pole is called the south direction is called the south pole. So for any magnet, there are two poles. One is north and other is south pole. Okay. So if you take a bar magnet, it's a bar magnet. If you hang this bar magnet by using a thread, then you can see that this magnet align in the direction of north-south direction. Okay. The symbol bar magnet is present inside the compass needle. That is why this compass needle attracts towards the magnet. Okay. This bar magnet attracts towards the other magnet. So this compass needle contains a small bar magnet. Then the like poles of magnet repels and unlike poles of the magnet attract each other. The like poles of magnet repels. These are two bar magnets, and it is the north pole, it is the south pole. In the same way, this is south and this is north. You can see, unlike the like poles, you can see like poles repels each other. Like poles repels. Then unlike poles, south and north, attract each other. Unlike poles attract, like poles repel each other. Like poles repels each other. This is a property of any bar magnet. Then listen, what is a magnetic field? What is simply the word magnetic field? The region surrounding a magnet in which the force of magnet can be detected is it to have a magnetic field. It is a magnet and there is a region around this magnet in which the force of this magnet can be detected. At that portion surrounding this magnet is known as magnetic field. Then what is magnetic field lines? It's a magnet. For any magnet, we can represent north and south poles. Then the magnetic field lines passes from north to south. Magnetic field lines are the imaginary lines started from north to south direction. Okay, it is the imaginary lines from north pole of magnet to the south pole. In other words, the lines along which the iron fillings align themselves to represent magnetic field lines. If you put iron fillings around the around a magnet, then you can see this iron fillings align in a specific direction. These lines are called magnetic field lines. These are imaginary lines of force. Okay, these are simply imaginary lines of force starting from north to the south. They always started from north to the south direction. Okay. Magnetic field lines has both magnitude and direction. It is a vector quantity. It includes both magnitude and direction. The direction is always from north to south pole, and the magnitude is calculated in Tesla. Okay, we discussed in the previous section that the unit of magnetic field strength is Tesla. SI unit is Tesla. Next question: what are the properties of magnetic field lines? We discussed about the magnetic field lines. What are the properties? This question is an important one and we have to study these properties. First one, magnetic field lines are emerged from north pole and ends at the south pole. Magnetic field lines always started from north to the south pole. Okay, started from north to the south pole. Then field lines are closed curves. These lines are closed curves. Okay, it's a continuous curve started from north to the south pole. It's a closed curve. The relative strength of the magnetic field is shown by the degree of closeness of the field lines. Listen here. The relative strength, how the capacity, what is the capacity of this magnet? What is the strength? How many field lines are present in unit area? That is the degree of closeness. How these field lines are closed. There is only these magnetic field lines. If this is the only magnetic field lines, then this magnet is weaker than this magnet. North, south. The number of field lines and the degree of closeness. How the magnetic field lines are closer. That measurement gives the relative strength of the magnet. Okay. The relative strength of the magnet is shown by the degree of closeness of the field line. This is an important point. How we can measure the strength of a magnet? By measuring the degree of closeness of the field lines. That is the answer. Then, magnetic field lines are never intersect each other. Is a property. Magnetic field lines never intersect. These magnetic field lines are separate lines, not intersect, never intersect these lines. These are the properties, important properties of the magnetic field lines. Okay. Then another question, what is the direction of the field lines inside a magnet? We discussed that magnetic field lines are closed curves. Okay. From north to south pole. But inside this magnet is a closed curve. Is a closed curve. So outside north to south, inside south to north. It's a closed curve. So north to south, inside the magnet, south to north. Inside the magnet, the direction of the field lines is from south to north pole. You have to note these all points. It's an important question. Okay, it may ask as one word question. Inside the magnet, the direction is south to north, but outside the magnet, the direction of magnetic field lines is north to south, and these are the properties. Magnetic field lines are never intersect. Why? We discussed the properties of magnetic field lines. Magnetic field lines are never intersect. Why? You want to find the reason for this. If the field lines intersect, this is a magnet and this is the north and south poles, then how the direction of the magnetic field can be found? You can find it by using a compass needle. Place a compass needle here. Place a compass needle here. The compass needle. And this line is the direction. Take a magnetic needle and place here. The direction should be in this way. The direction of that needle align like this. Okay. If you place that compass needle here, then you can see that the compass needle align in this direction. If you place compass needle here, then you can see the compass needle align in this direction. So these magnetic field lines are produced by joining these lines together. These are the direction produced by a compass needle. Are you clear it? Then, if the two magnetic field lines are intersect, Then what happened? Just draw another field lines here and one more line, but it intersects this direction. But this line intersect like this. If it is possible, then what is the direction of magnetic field, magnetic compass needle at this point? Place a compass needle here. Then you can find that the direction is here. If you place the compass needle here, then you get this direction. But in this condition, in this position, the compass needle give only one direction. It is not, it give only this direction. If it intersect, then at that point, this compass needle should give two directions at this point, but it is not possible. Compass needle only give this direction. It indicates that this field lines never intersect. If it intersects, then this compass needle should give 2 points, two direction at that single point. Is it possible to give this compass needle align this two direction at the same time? Is it possible to align the compass needle in different direction at the same time? Is it possible? No. That is the common understanding. It's not possible. It only passes like this. It never intersect. If the field lines intersect, if the field line intersect, it would mean that at that point of intersection, the compass needle would point towards two directions at the same time. It is not possible, so it implies that the field lines never intersect. Okay, if it intersect, then at that point of intersection, the compass needle should give 2 points, two directions at that point of intersection. Is it possible? No. That is why it implies that the field lines never intersect.